Here we go, nerds. Periodic table. We're going to talk about valency, which the fancy pants scientist will call the combining power of an element. So, what's the point? By the end of this, you should be able to A, identify the valency of elements in the main blocks. That's groups I to V, I. So, group 1 to 8. You want to be able to understand that a stable atom has 8 electrons in the outer shell. You also want to be able to explain that the formation of ions essentially creates charged atoms, and that's what causes things to, well, ionic compounds anyway, compounds to form when they just get attracted to each other because of the opposite charges. So, let's have a look. Now, what do you need to remember? You need to remember from year 9 that ionic compounds are metals combined with non-metals, and they're created by transferring electrons, and then they're held together by the attractions of the opposite charges. So you see, this one sends an electron over there. The chlorine now has a minus charge or a negative charge. The sodium has a positive charge. We'll talk about why in a minute. And because they have opposite charges, they're stuck together. All right, the octet rule. This is not why we need to have 8 musicians in a band. You don't, that's a funk band, and that means it's bad. The octet rule is that atoms are most stable if they have a filled or empty outer layer of electrons. Okay, we'll get to sodium and fluorine over here in a minute. So, with the exception of hydrogen and helium, a filled layer contains 8, and that's why it's called an octet. So, atoms will gain or lose electrons, and this creates ionic compounds, or they'll sometimes share electrons, and this is covalent compounds, which we're not going to talk about until semester 2. They will gain or lose or share electrons to fill up that empty space or to make the outer layer full. It takes energy to maintain an outer layer, and they want to do, the atoms not want to do, the atoms tend to do that which is easiest. So they'll do whichever requires the least energy. They'll drop down to that level. So just a quick look over here. So sodium has 11 electrons. So you've got 2 in this shell. That shell's full. The first shell only holds 2. 8 in the second shell. But in that final shell, that third shell, they only have 1. Now fluorine has 9. Okay, so it's got 2 in the outer shell, and it's got 7 in the outer shell. Now, by all means, fluorine could lose all 7 of these electrons, and there are ways to make that happen. But naturally, what it wants to do is it wants to take just 1 on, because that's easier. Sodium, it could take on an extra 7 electrons, but again, that's a pain, it's a hassle. It's so much easier for it to just lose that electron. And when we do, they will then join together and create an ionic compound. And the atoms become ions. They're still atoms, but they're charged atoms. Alright, so valency. We'll talk about what the charge is in a minute. So valency. Valency is the combining power, so the power of it to attract other things to it. And it's measured by how many hydrogens it can displace. So a sodium atom, which we see here, it will, because it's positive valency, it will take the place of a hydrogen, or how many hydrogens it can connect to it or combine with. So if something has a valency of -1, that means it can pull 1 hydrogen to it. If it has a valency of -3, it can pull 3 hydrogens to it. If something has a valency of +3, it can take the place of 3 hydrogens. Okay, so that's cool. Now, basically, valency, it can be measured as the charges of an ion formed by an atom when it loses or gains electrons. Okay, so while it's going for its stable outer shell, we look at the overall charge. That's its valency. Okay, so let's have a look. We have 11 protons in the middle and 11 electrons. The sodium loses that electron, as we discussed earlier, because it's just easier to do that. So it loses that bonus electron, which means it has 11 positives, 10 negatives, which means its overall charge is +1. That makes it a cation, which is fancy talk for positive charge. You need to know that word though, so don't let me just say fancy talk. It makes it a positive. It makes it a cation with a charge of +1. Chlorine gas gains an electron. Okay, so it's 17-17. So far it's neutral, but it takes this electron on. And it's now 18 negatives, 17 positives, which means its net charge is -1, and it's an anion. Okay, so an anion is the fancy science talk for negative ion. So it's an anion with a charge of -1. So here's our example over here. These two, when combined, make sodium chloride. But if just for example, this one here was a +2 instead of a +1, it would be then make NaCl2 because it would need two of these -1s to neutralize everything and make it all standard. All right, so ions. So I hope that makes sense. If this doesn't make sense, pause, go back to the beginning of it and go through it again and bring your questions to class, obviously. So ions, basically, the group number of the main block elements is how many electrons it has in the outer shell. Okay, so 8 gives you a stable atom. So this actually means that group 8, it's got a valency of 0. It doesn't react with anything, and that they're extremely stable. So if you've got less than 8, well then you become unstable. The atom will form an ion by losing or gaining electrons in whichever direction is easier to reach a stable shell. Okay, and here's our last example, I think. So here we have, that would be fluorine again. It's got +9 in the middle, 9 around there. It fills up that empty space, and you now have 9 protons, 10 electrons, so an overall net charge of -1. Now we look at magnesium. It's got 12 protons, 12 electrons. It loses those 2 electrons. It gives them to something else. You don't have to worry about where it's going right now, and that gives us a 12 positive charge of 12, negative charge of 10. Its overall charge, its net charge, is +2, and that's a cation. So the charge of an ion is the overall net charge once electrons have been gained or lost. And here's just a quick look at our table. We can see that. So here's group 1, 2, 3, 4, 5, 6, 7, 8, and you can add these numbers to it if you to your periodic table in your book. And here we see why. See, all the way down here, these are just the outer shells we can see. 1, 2, 3, 4 in the outer shell, 5 in the outer shell, 6 in the outer shell, 7 in the outer shell, 8 in the outer shell with the exception of helium because it's only got 1 shell. And if we look at that, that's why these are called the noble gases, and that's because they don't react. All right, that was it. I hope that made sense, and yeah, we'll see you in class.